So in this problem, I'm going to use the conservation of energy to calculate the kinetic energy of a rotating cylinder. It says that we will employ the work energy theorem to relate the work done on the cylinder to a change in its rotational kinetic energy. A light, flexible, non-stretching cable is wrapped several times around a winch drum. A solid cylinder with mass of 50 kilos and diameter of 0.12 meters that rotates about a stationary horizontal axis, turning on frictionless burdens. What we do know is that the free end of the cable is pulled with a constant force of magnitude 9 newtons for a distance of 2 meters. Then it unwinds without slipping, turning the cylinder as it does so. The question is, if the cylinder is initially at rest, what would be its final angular velocity and the final speed of the cable? Now, to find these both things, we first have to give a value for the radius, because we know the diameter is going to be 0.12, so half of it would be the radius. We need the radius to employ it in our equations so we can find the angular velocity and the cable and the final speed of the cable. Another thing that we know is that the kinetic energy is going to be equal to 1/2 times the moment of inertia times the angular velocity squared. And that's going to equal the work, or Fs. The work in this case is going to be the 9 newtons times the 2 meters, which is 18 joules. Next, the moment of inertia is going to be 1/2 mr squared. This is the formula for a solid disk, and this is what we're dealing now in this problem. So as we plug in the value, we have 1/2 times 50 kilos times 0.06 meters per square, and that should give us exactly 0.09 kilograms per meter square. Now that we have these two things, the work and the moment of inertia, we could solve for the angular velocity. So we have 18 joules equals 1/2 times 0.090 kilograms per meter square times the angular velocity squared. So as we solve for omega and we do the algebra, we get 20 radians per second as the angular velocity. Now, to find the final speed of the cable, we would find, or we're trying to look for the tangential velocity. In this case, it's going to be represented as the radius times omega. That's going to be equal to 0.060 times 20 radians per second, what we just found, and that should be 1.2 meters per second, our final speed.